Great. So I'll talk about sort of the new flow we're introducing for how to access more data and compute with Axiom. So as we discussed on the panel, the fundamental problem we're solving today is that smart contracts are data starved on Ethereum. They just can't access anything that's not in the current state. So you can illustrate this by looking at essentially the web front end of any dApp on Ethereum and just trying to identify which pieces of data a smart contract can actually access. And in the case of this Pudgy Penguins listing, you'll find it's basically just the current owner. And so as a result, developers work around this by either paying more to store more data in state or just reducing the security of their application. So paying more definitely works, but obviously it introduces a negative externality on every user of the application. On the other hand, reducing security also sometimes also works, but it reduces the composability of your application. Maybe your users trust you, but an application composing with you probably maybe does not even have users who know who you are. And so this is a difficult trade-off that developers face today. And so the question that we're trying to answer at Axiom is how we can scale data access and compute on-chain. So the starting point that we use is that the current block of Ethereum and any blockchain commits to the entire history of Ethereum. And then every past block commits to the state at that block and all the transactions and receipts at that block. And that means we can access the history with cryptographic techniques instead of consensus techniques that are fundamentally limited in scalability. And so how does that concretely work? If we want to access, say, a transaction from 1 million blocks ago, what we have to prove is to exhibit the intervening 1 million block headers, check that the Keccak hash of each of them appears in the next header, and then provide a Merkle proof of the transaction into the past block. Now, this operation is pretty expensive. First of all, there's 1 million block headers, and it can't really be done natively in the EVM. Now, with ZK, we can take this large, expensive computation, verify it in a zero-knowledge proof, and simply verify that proof on-chain. And so using this new way of accessing data in ZK lets us really scale the amount of data we're accessing, as well as compose these verified data proofs with proofs of computation. So in Axiom v2, we're introducing a new interface for accessing this data. We built a JavaScript REPL front end for developers to specify which pieces of historic data they want to access in real JavaScript. So we have an embedded DSL in JavaScript that lets you pick the piece of data you want to access, and also lets you specify a simple ZK circuit in JavaScript and export a client-side prover to generate a proof of the compute you want over that data. One caveat, it does not work on mobile. So here's the workflow we're introducing in Axiom v2. First, we'll start with your user on a web app. That user will generate a client-side proof that we export from Axiom REPL. That proof will be sent to our on-chain Axiom query contract, and our proving server is going to index that query and generate a proof of valid data access. So that proof verifies that all data mentioned in the compute proof was authentically present in the history of Ethereum, and also is the same as what's verified by the data proof. We aggregate these two proofs together and verify the final aggregate proof on-chain and send a callback with the results to your dApp contract. One important piece of developer experience that we've optimized for here is we implemented a universal aggregation circuit. What that means is that this circuit can take in any ZK circuit and any proof for that circuit and verify one against the other. As a result, all of the proofs generated by Axiom can be verified against the exact same on-chain verifier. even if the computations and data accessed by the developer are very different. That means that for a developer to use Axiom in their application, they don't need to deploy any new ZK-related smart contracts. All they need to do is write vanilla Solidity code. In fact, the only requirement to use Axiom results in your smart contract is to implement a specific callback shown here. We'll tell you the source chain of the data you're requesting, the caller that requested the data, some encodings called the query schema and query ID that are effectively hashes of the query, and finally, the results. If you implement this single callback on your smart contract, you can ingest ZK-verified data from Axiom. So within our Axiom REPL interface, we export a starter Next.js app that will allow you to generate client-side proofs in your user's browser today. You can check it out at repl.axiom.xyz. So that's it. So we're Axiom. You can check out our V2 on testnet. We encourage you to play around with Axiom REPL. In addition to accessing on-chain data, you can write basic ZK circuits in this JavaScript interface. And we encourage you to come discuss with us in Telegram at the QR code. Thanks so much.